So let's look at a recap of all the different types of SQLs that we've done thus far. SQLs, when we started, we said SQL stand for Structured Query Language, and we use SQL to query a database. You've got many records in a database, and we use these commands. These SQL commands are used to query the database. So here, to display all the fields, whenever you see the word display, remember it is a select statement. Even in an exam paper, when you see that select, it means you need, or if it's display, it means you need to use the select statement. Star means all the fields, and then from and your table name. So this is the compulsory part that every select statement must have. Then if you need to display, we know that's a select, but you only want to display some fields, not all the fields. You just want to display some of the fields. So in that instance, you'll just specify the name of the fields. So here it is the actor name. Okay, make sure you get the spelling right. It is the actor surname and it is the age. So those are the fields that we want displayed, and then from your table name. So again, quite straightforward. The third one, again, I'm only displaying two fields, the name and the contact numbers. Now you'll see that sometimes they try to trick you and they'll say display the name, and you have to know the field is not called a name. The field is called actor name. So when you are writing it in your select, you have to ensure that you use the name that exists in your table. And in this instance, cell number has a space in it, and because of the space, we enclose it inside of square brackets. Here we want to display, we could have many records, but we just want to display the top two. Okay, so when we're writing our select statement, before you start writing your fields, you just specify top and whatever number, however many you want. So select top two, and then these are your fields, actor name, and I want to display the cell number. This is usually useful after you've done some form of sorting, because if you've sorted your records, and if you have possibly a score field and you've sorted in ascending order, ascending lowest to highest, then your top two will be your two highest scores. So that is an ideal situation where you'd possibly want to make use of top. Then we looked at aliases. And alias, all that an alias does, you've got these headings, right? You've got these headings. An alias allows you to rename your headings. You can change the headings. If you don't use an alias, it simply uses whatever the field name is. So it just writes it using the field name, but using aliases, you can now rename. And to use an alias, you use the as. We use the as. So you can use an alias for each field. So here's actor name. Okay, for actor name, I'm using an alias. And then for actor surname, I'm using another alias. And then for age, I'm choosing not to use an alias because I'm happy with that field the way it is. So this is how you'd go about using your aliases, making use of the as. Just to take note that if you use an alias and as part of your alias you have a space, then you should, the same rule applies. If there are spaces, make sure you put them in square brackets. And if you're using an alias that does not have any spaces in it, then there's no need for you to use any square brackets. So here, I'm just going to change my color. Display the actor name, surname, and age in 10 years. So here we're looking at a calculated field. So we want the age in 10 years time. So you can perform a calculation, Okay, these are my standard fields, name and surname, and you can perform a calculation based on a field that's inside of the table. So you're taking the current age and you are adding 10 to it. And this field is just a column that is created temporarily in the database. It's not added into the database, so take note of that. And if you're using a calculated field, you could have used an alias, because you can see that if you don't use an alias, it comes up with a cryptic field. So then there's another function called format. Format allows you, if you want to get currency, for example, with the R sign in it. So format has two parameters. The first parameter, you can have a calculation, for example, or you can have a field. So here I've got a calculation, and then I've got a second parameter, which is what I want to format it to. In this case, it's currency, right? And here is the format statement. So format, the first parameter, which is your calculation, and then your second parameter, which is your currency. Guys, can you all please mute? I can hear some background noises. Some of you are not muted. Okay, so this is your format that you're using. So take note of this, because in the papers that we're going to be doing, you will be required to use the format in one of the questions. Then using round, you can round off to 1 decimal place, to no decimal places, to 2 decimal places, whatever you want. Similar to format, you will have your calculation. So that is your calculation. Okay, and the second parameter, you then specify how many decimal places you want to round off to. So in this case, I'm rounding off to 1 decimal place. And I've put in an alias, which then becomes my heading when it displays the data. Then we went on to working with dates. When you're working with a date, you can get the current date by simply saying date, open bracket and close round bracket. That's your current date. But you could also extract just the day from a date. So if you want the day, then you use the function day and in bracket DOB, which is date of birth. So you're going to get just the day from that date field. And if you want the month in exactly the same way, you will extract the month from a date field, or you could get the year from a date field as well. So these are functions that can be used to extract date, month, and year. And I think if I recall, one of the questions requires you to use this as well. Conditions, this is now, we now have the where statement coming in. So with the where statement, we are restricting our data. So it's not printing all the records, it's restricting it. In this case, we are saying the age is less than 20. Here we are saying annual earnings are greater than 75,000, right? That's the restriction. So you've got your compulsory part, select star from the table name, and then where, and you place your condition thereafter. More conditions. This condition is based on the surname, the actor surname, and because the actor surname is of type text, we make use of the double quotes. So that is important to take note of. In the previous example, we worked with numbers, and with numbers, you don't need to use quotes, but when you work with text, you need quotes. The next example works with a date. Whenever you work with a date, you enclose the date using a hash, right? That's just the rule when you're working with dates. The next, maybe I should also add, if you see a field called something like this, DOB, date of birth, and you can see the values in it is in that format, do not automatically assume that it is a date field. this does not tell us anything in terms of how the field is declared. You must go to the table structure. Look at the table structure. And if the table structure says this field is of date, then you assume, not assume, then you take it for granted. I can use day, month, and year. It is possible the field could have been declared of type text, and it could be in this format. And if it is of type text, then you cannot use date. You cannot use day, month, and year on a text field. So just be very careful when you're working with the table. The first thing you should do with the table is to look at the table structure and understand how each field is declared of what type. Here we've got a type that is Boolean, true or false. When it's defined in a table, it could be yes or no, which is the same as true, false. So when we are testing, we will test it against a true or a false value, and take note that true and false is understood. There's no need to have any quotes around it and turn it into a string. Another operator that's important is the like operator. With the like operator, there's two wildcards. The one wildcard is percentage. And the percentage means you can have 0 or more characters when you're searching for a particular pattern. And when you're using the underscore means I'm looking for one specific character. Not looking for it, it refers to one specific character. So here we are checking where the actor name is like, and the pattern is T. That means it starts with a T, and you can have any number of characters that will follow. The second one has a different pattern where it ends with a Y, and it could have anything before the Y. It must end off with a Y. So these are, this is how you would use the like operators. And you can see that when I'm using the like, I'm using it with quotes. So you generally use the like operator with a field that is of type text or string. Okay, you can use the like operator with that. You wouldn't use the like operator with numbers. So just keep that in mind. In this particular pattern, you've got a T and you've got percentages on either side. That means it must contain a T. It will contain a T in it. But it doesn't matter where the T is, but it can have a T in this field actor name. And if you look at this example, the pattern is a little different. That pattern means it must start with a 0. It could have any second character. It could be anything. And the third must be a 3, and thereafter anything could follow. So in other words, we're looking for sequences with 083 telephone numbers. We could even have 073. We could have 063, and 013 for that matter, anything. The second character could be anything. It just depends on what type of information that you have inside of the database. Here we then went on to look at multiple conditions. So we checked that age is greater than 20, and here we're checking age less than 40, and here is the AND operator. So look at how the conditions are written: age greater than 20 and age less than 40. So the conditions are complete. Do not say age greater than 20 and less than 40. That's an incomplete condition. Here I can see age greater than 20 and age less than 40. So those are complete conditions, and means both of those conditions must hold true. In the second one, we also have two conditions where the annual earnings are greater than 75 105,000 and it's less than 130,000. So that means both of those conditions need to hold true. Here we are using the OR operator. Again, two conditions: date of birth greater than or earnings. Whenever you use the OR, you just need one of these two conditions to hold true. To use the not. So whatever I've got here, age greater than 50, not means the opposite of that. So we're going to be looking at age less than equal to 50, when we say we're not age greater than 50. Similarly, if we say is local is true, not means you're not looking at those cases where it is true, you're looking at all other cases. And in this instance, the only other case is when it is equal to false. We went on to look at the in operator. So we're checking if the surname is in here. In other words, if the surname is equal to this or it is equal to that. So whenever you use the in operator, it's equivalent to using an or with multiple conditions. In other words, where actor surname equals poo or actor surname equals pig. So that's an alternative to using the in. Similarly, you have the between operator, and the between operator is similar to the and. So here you're saying where annual earnings is between this value and that value. If you had to write it using the and, you would have said where annual earnings is greater than or equal to 50,000 and annual earnings less than or equal to 100,000. So that would have been the equivalent. We then went on to sorting, and when we are using sorting, we use order by, and we sort by a particular field, and we specify ascending or descending order. So by default, ascending order is in place, so you don't really need to specify ascending order. If you want it in descending order, then you must have DESC, and it should be in uppercase when you are writing it. So this will sort all the actor names. It will sort on actor name in descending order. Then if you are sorting on two fields, so here, this is your primary field that you are sorting on. And because you've got a second field, that becomes your secondary field. So sorting will only take place on the primary field, only on that. The only time the secondary field will kick in is when the primary field has duplicates. So if the primary field sorts and there are duplicates on the actor name, then it will sort those actor names on the secondary field, which is surname, and it will put that in descending order. So this is sorting with a primary and a secondary field. You can also sort and you can have a restriction. So here you're selecting those where they are local and you are sorting whatever the result is in ascending order. So don't think that when you use the order by, you're restricted and you can't use a where. That can still be in place as well. We went on to aggregate functions. If you want the total number, then you'll say count star. If you want total number, you could do the total number with count star, and you can put a condition. So it'll count the number of actors where the annual earnings are greater than 100,000. You want total annual earnings, then we use the aggregate function sum. And here you can use an aggregate function as well with a where statement as we did earlier on. Then you can work out average. That's also an aggregate function, average. And you can then work out max and min. These are all aggregate functions that can be used. Then we created groups, and there was a rule we used when we created groups. We said when you are using an aggregate function like max together with a normal variable, you have to group by that variable. The reason being is that an aggregate function returns a single value, whilst a normal variable wants to return every record. So that's like a contradiction. So when you group by that variable, it will return aggregates for each of the groups. So here you will see it's got the maximum age for those who are local, and it's got a second group, a second aggregate for the oldest age for those who are not local. And then we also did an example where we looked at, there we are, this is an aggregate, and I've got more than one fields, so I have to group by both of those fields for it to work. And then finally, we went on to say that if you want to use an aggregate, inside of a condition. Now we know that when you work with a condition, we usually use the where. Clause. But in this instance, I'm using an aggregate. And when you want to put that into a condition, we then use the having clause. So having and where are similar, both work with conditions, but having works only with aggregate functions. And again, keep that in mind. One of the questions in the exam papers requires you to use this. Then we went on to extracting information from two tables. And I want to get the name, I want to get the job, and I want to get the location from both the tables. So when you want to extract information from two tables, you have to have a linking field. And here, the linking field is the department number. It links the two tables. So this is called your foreign key, okay, and this is your primary key that links the two. So because I'm extracting information from two tables, okay, I just want to change my pen color again. This time I'm going to say select, there's my three fields, right? Location is from one table and these two are from another table. So from first table, second table, and then you have to create a join. This is called a join. So you'll say where table name dot the dep number equals the table name dot dep number, because the dep number joins the two tables together. And if you don't have the join, you're going to create something called a Cartesian product, where it's going to associate the one record in the one table with every record in the other table, which is not true. The shorter way we discussed that this way you can do this is in the from, you can kind of put an alias where you'll say TBL employee E and TBL location L. So now when I'm referring to the tables, I can say E.dep number equals L.dep number using those aliases. So that is how you would extract information from two tables, multiple tables. Then we started going on to the insert statement. So for the first time, we are now making a change to the database. Previously, we were just displaying information in the database. So here we're adding a new record. And with the insert, there's three keywords: insert, into, and values. So those are three you must remember. So you'll say insert into your table name, and you specify all the fields for the table, and then you have all the values that correspond to each field. So you had fields, and there has to be this one-to-one mapping for your value. There has to be this one-to-one mapping for your value and your field that you specified. You cannot have 5 field names and 4 values. That's going to create an error. There must be this one-to-one mapping that takes place. There is a shortcut though, and the shortcut is that you can omit the fields. If you look at the previous example, it's exactly the same example. You can omit the fields provided you are inserting all the values, and the values that you are inserting are in the same order as the order of the table. So in the table, the actor name comes first, the actor surname, then the date of birth, then the age, cell number, then the is local, and then the annual earnings. So as long as the order is the same and you are inserting all the values, you can then omit putting in or writing in the field names. But if you are inserting some of the values, in other words, you're not inserting all the values, then it's compulsory. It's compulsory to have this. And again, you're still going to maintain your one-to-one mapping for each of these. So it's insert into table name. You put down your fields, values, and then the values that correspond to those fields. Then we did the update statement. The keywords here was update and set. Update, set. So you update your table name and set some field to some value. So this is going to be set. And usually we have a where. The where is not compulsory, right? This is the compulsory part. But when we use a where, we can now restrict the number of records that are being updated. So where actor ID equals 2 means this change is only going to take place for that actor ID. I'm changing 2 fields, the annual earnings, and I'm changing the cell number for that same actor ID. So you can change multiple fields as well. And in this example, there's no where. So I've just got an update and a set. Now this means that every record is going to change, is going to be updated. So what we are working out 5%. This will work out 5% of the annual earnings, and we are adding it to the existing value, which means we are increasing the annual earnings by 5%, and we're storing it back into the annual earning fields. So this could be like a raise. We are giving all our employees a raise, or all the actors, we're giving them a raise of 5%, and there's no where clause to restrict the data. Finally, we're coming to the delete, where we're removing records in the table. This can be dangerous. You have to be a bit cautious how it is used. So delete from TBL actors where actor ID equals 1. So it's going to delete that particular record. Here, it's going to delete, in the previous example, it would delete only one record because this is the primary key. Here, it's going to delete multiple records because I've got more than one record that has the is local equals false. So all instances where is local equals false will now be deleted. And then if you go and put something as dangerous as this, you're going to wipe out the contents of your table. So you're going to have to be very careful in the way you use the delete statement.